if it makes sense, you will make sense of mathematics. But I also believe that that is true of art. So students who believe that art makes sense will attempt to make sense of the art. And therefore, I think that we all need to help students make sense of mathematics and art. I am a firm believer that it's not one or the other. Some people think that it should be either art or mathematics, and they don't necessarily see themselves as mathematicians if they believe that they are artsy people. Or if you're a mathsy person, people think, oh, no, drawing's not for me, I can't do that. But I think that's actually completely wrong. I think that both of them have a lot to learn from each other. I'm going to just give a quote of Albert Einstein. I'm very fond of him. The greatest scientists, he said, were artists as well. And I truly believe that when science meets art and the two work together, the results can be remarkably constructive and fantastic. So often when people think about science and maths, they think about maths is abstract information, it's data, it's formulas that are hard to read and understand and interpret. But most of it is based in reality and can be linked to practical problem solving. And problem solving requires creativity. And then, of course, creativity involves imagination, and imagination is visualization. And these are traits that artists also possess and use. So I think that artists and mathematicians have a lot more in common than is commonly thought. In earlier times, there was actually not such a great distinction between art and science. It was often intertwined. Both disciplines shared their origins in representation and interpretation of nature, but over time, the methodologies for these two different disciplines diverged, and that's, I think, where people started thinking of them as so different. I just wanted to show you two pictures done by a Polish artist, and I'm not exactly sure how his surname is pronounced, but I think he's Julius Cossack. And if you look at these two images of horses, he apparently visited a lot of abattoirs and did a huge amount of dissections and really got to study and know the physical structure, the bones, the muscles, how the muscles contracted, how they worked, to be able to do these excellent artworks where he could represent very clearly how the horses moved. And there's actually some of the people that say that a lot of his work was used later on in some of the presentations that they did for anatomy classes, and that they learned a lot about the movement of horses actually from his artworks. So I think artists and mathematicians are both driven to observe and create, and they largely reside in different cultural spheres, but when they're brought together either by accident or intentionally, I think that a huge amount of lovely stuff can result from it. Another example of science and art and maths that comes together is the Sagrada Familia in Barcelona in Spain. It's the largest unfinished Catholic church in the world. I think they're still busy completing it, and it's already been done for centuries. But if you look at this picture of the beautiful structure, and this is an absolute example of where geometry and maths and calculation, engineering and technology and beauty all come together to create this amazing construction, which they are still inventing. The person who, or the Sagrada family who designed this, I think those people were real dreamers, and they're still trying to really build in and finish what they dreamt about in this cathedral. So I come back to my question, maths and art. Do the two belong together? Okay, so let's go back to the solid research. What does the research say? Research has shown that motivation and engagement can effectively be boosted by emotional involvement and creative activities, which can also lead to new discoveries about the complex relationship between learning, emotions, and creativity. And I think this is what the combination of maths and art brings together. So why combine maths and art? So why did we then decide to combine maths and art? And this is now assuming that art's not just an add-on, but that it's really a concept used in the learning of STEM education. we think that it can provide motivation and engagement, both in the maths and in the art class. So this is not just all about maths, but also in the art class. We really believe that it can enrich both mathematics and art learning. And then also by enhancing multidisciplinary or transdisciplinary STEAM learning, so transdisciplinary where we combine the different disciplines and bring in critical thinking approaches. It also it draws in strong cultural embeddedness and social impact. So we started a math art competition project many years ago in 2017. We sat down around the table and decided how are we going to motivate people to combine these two disciplines that are often, people don't even want to think of how they can be combined, but when they are, they really bring out a lot of fireworks. So we had to try and see how we could combine this and make it something that people would at least try out. So we started a competition in 2018, and what we discovered through the competition was much more than just the maths. The artworks that we received referenced, and I'm going to show you some examples just now, reference classic math art connections, such as, of course, things that you can easily Google, like the golden ratio, spirals, infinity, and then the geometric figures, triangles, etc., translations, tessellations. So these were the things that we found that the classic math art connections that the kids found. But the learners' own interpretations of the artwork also made it possible for us in the paragraphs that they wrote to see a little bit more, to get a little bit of a view in their cognitive, emotional, and perceptual patterns that they used. So that was quite awesome to look at the paragraphs. So we asked them to draw an artwork according to a theme, and I'm not going to do or say too much about that, but we used these paragraphs that they wrote about their artworks to actually gather a lot more information about their thinking as well. The artworks contained, of course, several personal reflections, unique discoveries, and references to the ethnomathematical connections within the African culture, which to us was also great. So what did the competition bring? It also brought a lot of recognition to schools and learners. So learners of all races, of all language groups, everything in the whole country were encouraged to take part and to win something. We had a very, very encouraging email the other day from a teacher, or actually a parent, who said that their learner was not necessarily seen as good at maths, but in winning a prize at the competition, they actually were awarded, together with the maths learners, a prize which, and of course, boosted the child's self-esteem, and also where the child, of course, might not even be invited to the prize giving, also received a prize, which was great and fantastic. Okay, so people always think that maths does not equal emotion and there should be no emotions involved. But even if you just have an aha moment in a maths sum and have some success, there's already a lot of emotion. But there's lots of other emotion as well. And through the competition in here, you'll see some of the artworks that were received during the competition or through the years, where children recognized in their artworks their feelings and emotions about maths classes. So feelings of heartbrokenness, feelings of being measured, not just in the maths class, but also in their teenage groups. During COVID, we had learners that expressed, first of all, the difficulty with coping, the life and death situations, also coping with being clustered inside or confined to their houses or behind masks. And then the learner on the right there, you'll see how he says that he feels like he's a split personality in the maths class. On the one side, wanting to come out and be colorful, on the other side, feeling very constrained. But the children also expressed their feelings of being captivated by maths and being turned almost into some kind of a superhero. Other children expressed their feelings of maths being a monster, or shattered faces and heartbrokenness. Learners also expressed through their artworks. This learner drew her maths class and said, my class is a grade 11D class, and with them they make math exciting. In grade 11D, we love maths. So they expressed not just negative, but also their positive feelings. The learners also described their concerns about current world issues such as poaching and the destruction of nature and pollution. but also other world issues such as energy resources and corruption issues inside the world. But more than that, we were also excited about the way that they combined or they used common maths work that they were doing. For example, this is a grade 11 maths theorem of the angle at the center of the circle is double the angle that is subscribed at the circumference of the circle. And this, what an amazing, beautiful drawing of a maths theorem. And why can't we do this in our maths classes? Another one here was more a junior learner that was studying pi, and how she said that it's just not pi, and yes, it's the number 3,14, etc. But how she said it fascinates her for any circle, it doesn't matter what size, the ratio always equals pi. Have you ever thought about that? How pi actually relates to any circle, no matter which circle you're looking at. Now, this is just an extract of the paragraph that she wrote, but I thought that was quite profound, how this stimulated the learners to actually really go into depth in these mathematical concepts. And then it also stimulated kids to go further, not just with the regular CAPS and school maths programs that they do, but also to look at something that was more advanced, like the Fourier transform or synchronicity, which is something that the music people know a lot about, and that she linked this to dancing and all of the other synchronous occurrences that happen and with mathematics. And then fractals, which is also one of the more newer branches of mathematics. Other math topics, such as the Nemeth code, which is the way that the science and maths is explained in Braille, which I thought was also quite interesting. And then the knot theory, which also has a relation to a lot of cultural patterns, etc. Lovely. But also visualizing something that is as abstract as when you're dividing with 0, the answer is undefined. It's not defined in our number system. And this learner drew an artwork to just try and describe what they feel is undefined, or how dividing with 0 can look like if you would visually represent it. And this, I think, is such a powerful way of representing a lot of maths concepts that sometimes, or to try and represent them in a way that might make them more understandable to others around them. The kids also expressed a lot about their heritage, and this artist here said the dress the woman is wearing in the artwork is very similar to the dress my mother constructed when I was little. It always stood out amongst the other things she made because of the shapes and the bright colors I used in it. Looking back, I realized you had to have a good understanding of maths to make a dress like that. The kids also love cartoons and humor, and they brought in a lot of cartoons and humor, something I think we must keep at the back of our minds when we're teaching maths and humor. Often a lot of what we remember back from school days, other than maybe some sad incidents, are actually the times when we laughed about something. So why not use laughter and humor as something to teach with as well? And then, of course, we were mathematicians, but we were quite educated as far as the art topics were concerned as well. And the children used and combined these quite clever, where this child surrealism to also incorporate geometric optical illusion in her artwork, which I think was beautiful. Also, the art competition provided a lot of network opportunities. So this young learner had the opportunity to meet a Hungarian art professor, which I think was also such an inspiring moment for her. A lot of the parents actually getting together from all over the country to get together to chat about the artworks as they were looking at the children's different artworks, being able to discuss that as well. Then we also have an opportunity to invite other people from all over the world, people who are very experts in the world of maths and arts and science, and a lot of the learners get an opportunity to meet them as well. And here we have just one of the workshops. And I don't know if you can see the guy on the left here. You can barely see him, just his cap peeking out. He was actually the taxi driver, and the two ladies are two of the teachers. And there was no space in the workshop room for them actually to join the kids at tables. So they were standing at a little table at the back where we packed out some of the art supplies and having just as much fun with art and maths. And the taxi driver afterwards actually said that if he had done maths in this way, he might have actually finished maths and done maths until grade 12. And the two ladies are actually art teachers having just as much fun with the mathematics. Here's another few pictures of some of the workshops where kids are enjoying and having a lot of fun. And this is what we want to teach them. Creating is fun, and then we are doing maths as well. So bring art into the maths classroom and maths into the art classroom is what our motto is. Okay, let's get down to the practicals. I think I've shown you a whole lot of examples of how art can be brought into the, or combined with mathematics, but I think it's more than just a visual. It also includes, of course, music and dance and drama and sculpture. So we shouldn't just limit ourselves to thinking maths and drawing and colors. Let's take something simple such as quadrilaterals, for example. Instead of just starting out with quadrilaterals and maybe adding some colorful pictures, one could actually do something like a rap. Now, you won't be able to hear this video, but this young gentleman here is rapping out 1, 2, 3, 4. Oh, those are quadrilaterals, and he was rapping out the whole or a song to explain what quadrilaterals are, how they're formed, and what different types of quadrilaterals are. Okay, so music in a maths class, why not? Song lyrics can be used in the mathematics classroom in a variety of situations. For example, use a lyric about a maths topic, like I've just explained, the maths topic talk for that day. And well, if you're a maths teacher like me, then maybe that's a bit of a challenging thing. So why not talk to the maths, or the maths person at school could talk to the art or the music teacher and think about a maths topic. But don't forget the kids. The kids are absolutely fantastic. So in every maths class, if you ask, I'm sure you're going to find one or two of them that are quite willing to make up a lyric about a maths topic. Then also playing a related song and then posing a follow-up question or activity. So having them listen to a song and then asking something about, if we were to look at this song, what was it describing, and then relate it to your maths class. When I was pregnant, I remember it was quite in fashion to play classical music to your unborn baby. And as I was teaching, I thought, oh, well, if I can play this to my unborn baby, I'm pretty sure I can actually play this to my maths class as well. And I remember the first lesson I played the classical music. Some of the learners came to me afterwards and said, man, what's this now? What are we listening to? But afterwards, they would actually ask me if I forgot to put on the music. Ma'am, why aren't we listening to music today? So I don't know. I have no proof that it actually helped, but it definitely did help to have the kids quiet in class. Then also have it as a homework assignment. Have learners write a lyric or act out something as an out of class assignment or requirement assignment, or even when you're doing a maths project, instead of having just a project where they write up something, have them introduce the math topic in a way that is either musical or with a bit of drama or with a rap or something like that. And then, yes, explore the connections between mathematics and music. Something like the Kwaito music or Mendoza's and Kalakata has got a very definite 4-beat. So this I used once in a workshop with teachers and learners that wanted to learn counting in 4s or multiples of 4. So the Kwaito music, 1, 2, 3, 4, 5, 6, 7, 8, and one can actually count it out loud as the music is playing. The sound of pi. We did workshops with pi. I know Pi Day nowadays in a lot of maths classes is quite a lot of fun, and one can actually play it on the piano. And if you Google this, I'm sure you're going to find lots of examples of doing that. Sorry, I'm past the video. I'm not going to play it now. And then just a simple proof like proving the theorem of Pythagoras in grade 8. Instead of doing the boring one can do it like a tangram puzzle. This little example here is something where you almost prove it using a tangram, or even using origami and folding bits and pieces together. So I think as an activity today, what I'm going to do is, sorry, my I hope I'm still on time. The presenters must please stop me, the technicians, if I'm going over time. I just wanted to do a little short activity with everybody to use origami and to fold an isosceles triangle. So just to get everybody stimulated into thinking how in a very quick way one can combine origami and a bit of maths as well. So let's do this together. I said to the workshop leaders to please ask everybody to have an A5 page ready, or an A4 page, but if you divide it into 2 pages or tear it up in half, A5, otherwise use the A4 page, that's great. And what the assignment is I want you to fold an isosceles triangle with a page, but there's a bit of a twist to it. You can only use 2 folds. Now, for those of you that might not, or that might be in the foundation phase, I'm not sure if everybody knows what an isosceles triangle is, or maybe you can't remember, you might not be able to remember, but an isosceles triangle is a triangle where 2 sides of the triangle are equal in length, and then of course 2 angles are equal in size as well. So how would one go about folding an isosceles triangle? Now I'm going to see if I can put my visualizer on the screen, and then I'm going to do this with everybody. Okay, can everybody see the page I have on screen? I hope so. Is there anybody who can say yes or no? Can everybody see the page?
Yes, we can see it.
Oh, fantastic. Great. Okay, so how do we fold the isosceles triangle? Now, I think time's running out, so I think I'm going to go ahead and actually do it. So you take your A5 piece of paper, so it's just the A4, divide it into A5, and then you start out by asking yourself, how would you normally, if you had a piece of paper like that and you wanted a square? So this is a rectangular shape. We want a square shape. So first of all, in the art or the maths class, one could go into what is a rectangle, have the learners measure out the 2 sides, see that the opposite sides are equal, but that they're not the same length. So these sides are longer, these are shorter. So this is why it's called a rectangle. But how are we going to get a square? Okay, I'm sure all of you know the method of folding over the page so that you have, you fold it nicely there in the corner, over to that side, and you press it over, and you would open it up. Then you have a square. But okay, we're not going to do that second fold now, so we're just going to fold it over like that. And what we have here is actually something that's called a trapezium or a trapezoid. A trapezium. So the 2 opposite sides are parallel, but they're not necessarily equal in length. These 2 sides are not parallel. Okay, but now we still don't have our isosceles triangle, and remember I said only 2 folds. So we've done 1 fold. How are we going to fold, or where are we going to put the second fold in order to get an isosceles triangle? So what we're going to do is we're going to take over here where we have the slanted side of the side coming up. Over there, we're going to take that corner there next to this one, and you're going to bring the corner over and make the fold in exactly the place as the fold there, and put this side on that side there, and then press in the fold. Okay, there we are. Press it down. And now we have an isosceles triangle. We have a triangle with, let me turn it over this way, because this is the way that people generally look at it in the maths class. We have the 2 base angles that are equal. I think I didn't fold very nicely. And then 2 sides that are equal in length. So these 2 angles are equal to each other. And that side there, or that angle over there, is a little bit smaller. And we have 2 equal sides. So how can we now go further and ask a few more questions? So first of all, we could ask the learners, get out your protractors, measure the angles, get out a protractor, and we could actually measure the angles. So what's the size of this angle over here? And I love doing constructions, especially with the more junior grades in mathematics. I think it's so important. If we look at the protractor here, that angle is 45 degrees. The two angles at the bottom here, I think because mine's not so accurately folded, might not be exactly the same, but they should be more or less 67,5 degrees, but they're equal to each other. So the two of them are 67,5 degrees, and the one at the top, 45 degrees. Okay, now, but that hasn't really been so much fireworks. Now the question that we can ask is, will these shaped triangles actually tessellate? And then explain to learners, okay, what is tessellation or tiling? Tessellation or tiling is when you place objects or figures next to each other so that they don't overlap, but they also don't have any gaps in between. So, okay, one can now play around and have a whole lot of, or make a whole lot of these triangles and have your learners making them in all kinds of nice colors, and then place them around a point to see whether we can actually tile them and make something or have them tessellate. So what do you say, everybody? Is there anybody who wants to offer an opinion? Do you think that these triangles are going to be able to tessellate around this point? I don't hear anybody, any answers. But okay, let's continue. So if I continue placing the triangles around that point. Aha! And there they actually do tessellate. So they can fill a whole area there, the whole area, and no gaps. Okay, maybe not.
Sorry, Dr. Carine, can I stop you? Yes. This is Dr. Carine. Can you hear me?
I can hear you.
This has just been amazing, but I just want to say, sorry, we are running out of time. We've got 5 minutes left for questions and answers. I don't know if you wanted to rather, they can answer it answer it maybe in the, they can connect with you on the speaker, with the app later on, or how would you like to do it? Just do you want another 30 seconds with this project of yours?
I can quickly just show just something. I just want to show everybody that the total shape that we're getting here is actually an octagon, and octagons don't tessellate. Okay, I'm going to stop that share here.
Beautiful.
And then we can go back to the chat room. If there are any questions, I know that there were a few questions with regards to the maths, but
yes, if I can just guide this, sorry, because we are running out of time. I see a lot of the questions have been asked before, but I think while you were doing the project, you have answered some of them. But I think mainly the huge thing with these is they want to know, how can they incorporate more of these tasks and sessions. So if you want to answer it, but I think, like I said just now, with the Wova app, they can actually connect with you directly, or in the community chat, we could start something, and those questions then will be able to be able to answer it. I don't think we're going to be able to go through all the questions now, unless you want to quickly look at 1 or 2 of them and respond. Dr. Carine, can you hear me?
Okay, I'm sorry. I think that what happened was my video. It was the camera, actually the camera video.
Yes, I think it's because it's the 2 cameras maybe interfering with one another.
Yeah, I think that might be the thing.
Are you able to look at the chats, the questions quickly? Would you like me to?
I was looking at the questions and answers that were polled on the system beforehand. So the other questions maybe. In the chat, let me quickly see the questions in the chat. Okay, I can't, those questions, no. All right, let me rather look at the questions and answers that were on the chat room there. So the first one was, how can the integration of art in the math room benefit students who may struggle with traditional mathematical approaches? I think if I look at that question, the amazing thing is that a lot of our learners in the maths class don't necessarily think analytically. And although traditionally people do think that mathematicians are more analytical, I think there are a lot of studies that have proven that a lot of kids that sitting in our maths class are not necessarily, don't think analytically, and won't necessarily find an aha moment in just seeing a sum being demonstrated in chalk and talk on the board and an answer found. So how we can integrate art in the maths class and benefit everybody is by including different ways of looking at maths, so including different ways of representing different theorems, different ways of interpreting it, also using song, lyrics, or dance, art, drama, all of those different ways of teaching it. So I think that could all be incorporated very easily. I don't know if that answered the question. It was Dominique Maritz who answered that question. I had Chloe Sinosi who asked the question, how do I integrate art into the mathematics classroom, specifically for the foundation phase? I must acknowledge, Chloe, I'm sorry, I have never taught foundation phase, but if I look at that, I think that one could easily incorporate that with in the foundation phase and using things like maybe the tessellations and transformations that we used here, important things like teaching children how to rotate, but also the turning around a certain point, also pointing out things like angles, or starting out the concept of angles, the amount that you turn. I think all of that, and then bringing that in and demonstrating it either with a dance or with actual pictures of different things and showing them the different angles in the, but other than that, I'm open to any of the foundation phase people in this group who can help me with that.
So, sorry, Dr. Carine, I'm going to have to interrupt you again. I feel terrible. I mean, you can see there's such a huge demand in what you have just presented to all the teachers. And I just want to once again tell them that this conversation is not ending. They are going to bombard you with questions because your details are on if you look under agenda, where it says speakers, they are going to be connecting with you. And I think they're going to be asking you many questions. Thank you very much for this session. It was really informative.
Thank you very much. Thank you very much, everybody. And I really enjoyed it. And I hope you enjoy the rest of the conference. And I'd love to get more questions and also suggestions if there are people who've had some really awesome ways of doing this.
Thank you.